Hi everyone. As we go through the disclaimer, I would take the opportunity to thank the organizers of the workshop to let me present my work on software in medical robotics. So, I work for Stotz Venture One. Now, Venture One is the new arm of Karl Stotz. Karl Stotz is a family owned business with 9,400 employees worldwide, annual revenues of 2.17 billion, with 70 plus subsidiaries and around 13,000 plus products. It is the saying if you've been in an operating room, the chances are very high that you would have been touched with a Stotz instrument or products. Software trends in engineering systems. In a recent MathWorks European Advisory Board meeting that I was a part of were software factory, cloud, and Gen AI. Now, a robotics assisted surgery system is no different than a complex engineering system. Through this presentation, I would like to point out what steps are being done to leverage on these trends in a RAS system, also called as a robotics assisted surgery system. Before we move forward, I would like to show you a video that was shot at the recent SRS conference in Orlando.
The future of surgical robotics is very bright. The capability of robotics, I think, is going to grow exponentially based not on the hardware, but on the software.
Yeah, you heard it right. Software is the key. And with that in mind, I would like to say, or I believe, that if you're doing something smart, then you must be doing something software defined. And with that, I'm very happy to present to you MedOS, which is enabling software defined medical robotics. Hi, everyone. My name is Shashank Sharma, and I am Associate Director for Robotics Software at Stotz Venture One. Now, before we move forward, I would like to explain why software defines something, right? So recently we had some talks with some surgeons, and Professor Wilhelm is a famous surgeon in Munich. And during our interactions with him, he told me that for him, a RAS system is a very individualized and comfortable scissor with a very sharp blade. For him, the hardware is not the differentiator. He prefers to have a surgical experience which is tailored for his preferences with the latest AI enabled software and easy updates. So basically, what he wants to say is that he sees the system, his RAS system, right now like an old Nokia 3315 cell phone. And this cell phone is what he wants it to be transformed to an Android based smartphone system. Yeah. So it does not matter that the phone belongs to him or his wife, he can have the same piece of hardware, but through the software experience, he can change the overall look and feel of his system. So if Wilhelm or like Professor Wilhelm takes the phone of his wife or his own phone, even though they are the same model numbers from the same manufacturer, his experience on his wife's phone is totally different because the same phone is totally modified by the software updates. We also see that the average time to product launch is getting less and less. The number of features requested is increasing. The lines of software is also increasing every year. What we also foresee is that if you have a product and you divide it into the hardware and the software revenue streams, it is a well known fact that the dollar value of the software services will be significant revenue generators in the future. Now I wanted now I wanted to talk about the software defined in medical robotics, to be specific. I take as a reference other regulated industries here, like automotive, service robotics, and aerospace. Now, why do I take these industries? Because in all these industries, human lives is at risk, right? And on the x-axis you see here, I have written the software defined nest in that industry. So the penetration. Now these are just numbers. These are not absolute numbers. These are relative numbers, and I try to put these numbers to justify a point. Now you can see the regulatory part is very high in automotive and in aerospace. Now some of you might argue that the medical domain is highly regulatory, but then I would like to bring you the fact to your notice that the regulatory bodies are working on risks, and these risks are defined based on lives at risk. So if an aircraft is like flying up in the air and there are 100,000 aircraft flying at a given time with 300 passengers each, one of these aircrafts has a bug. Suddenly, all of those 100,000 model types with 300 people each, their lives is at risk. Whereas if you see from a medical robotics side, let's say for Intuitive, they have 8,000 systems installed as of now. And if all of them have a bug, then only 8,000 lives are at risk. So this is where I would like to differ and point out that I believe that the medical robotics regulatory is slightly less difficult than automotive or aerospace. On the x-axis, we see software definedness. So we can think of this like a penetration in software definedness. Now, if you do a Google search on software defined vehicles, you will have so many lists. However, if you do software defined medical robotics, you might not get any search hit. And this also affects the amount of standardization. Now, inside automotive, you can replace a car tire with some other brand based on the same specifications, but this is very hard to do in in a medical robotics field. Now, before I go forward, I would like to point out that why I believe these numbers are like that and why medical robotics is lagging in these three like parameters. To prove that point, you can see I'm showing some data of Dr. Washington. Yeah, he's the senior VP of Medtronic, which he joined this company in 2023. Now, what do you think his background would have been as a VP or CTO of Medtronic? I would suggest that his background would be medical, robotics, AI, and whatnot. Imagine he was working at Amazon Labs in consumer robotics, and before that at Ford Motor Company, and before that at Lockheed Martin. Maybe this proves that in the medical field, we have a lot to learn from other fields because there is so much more to do when software comes into picture. With that clear, I would like to talk about some numbers which are very, very clear. So, what's happening in the RAS market? The CAGR is expected to be at 13.7%. We are expecting a 3 times growth from 7.2 to 21.5 billion. And what's interesting is that Intuitive has 80% of this market share. And now, with 80% of that market share, it is able to generate around 6.2 billion of revenues in 22 with 68% gross profit margin. Now, this means we have a growing market. There is only one company that takes 80% of the share. So now everybody wants to enter that market where the profit margins are actually very high. But they are challenges. So on the left hand side, you will see that there are around 300 million surgeries being done, out of which only 2.3% surgeries are done through a robot. Around 15% of these surgeries are done by laparoscope. The challenges are the cost of a surgery from a robot is very high as compared to a laparoscopic surgery. This leads to very low market penetration. However, you must say that from this less than 1% of the addressable market being penetrated, Intuitive is still able to make $6.8 billion. Now, that's the catch. For new companies, they have like challenges that the regulatory burden is increasing with time. 86% of medtech startups face regulatory hurdles. We also see that around 75% of new entrants to the medtech sector fail in the first 3 years because of cost pressure, profitability, and other issues. So now we discussed the market, we discussed it's an enticing market. However, there are also some challenges. Now, I would like to bring the problem statement that we would actually like to solve. If I want to build up a robotic assisted surgery system, it takes more than 8 years to develop that product. So, imagine for people who are startups or those people who want to build systems for these RAS or like subsystems for this RAS system. There might be some research group in a university, or they might be even established RAS companies, and they might be willing to work on a winning like product idea. However, they are faced with these bag of problems, which I call as the lack of skilled resources, complex system integration, no code reuse. The whole solution is developed 3 times. The regulatory issues. There is hardly anything off the shelf available. Reinventing the wheel like scenario is always done, and the software potential is not leveraged. To give you some data on this, during a recent talk with some people from J&J, I was told that it take around 8 months for a new joinee in their robotics team to write the first line of usable software code. Just a few minutes ago, I was talking with some guys at Intuitive, and they were saying it takes them 6 months for a new joinee to write some piece of usable code. On top of that, making a robotic system work is not an easy task. There are a lot of things to fix. It involves a lot of know-how, and we do not have the number of these skilled resources at a big number. Now, what we're trying to solve is that imagine all these users want to have a stellar product, and then we make a bridge for all these like problems. Yeah, this is what the problem that MedOS actually solves. So the solution how we do this is through building an Android for medical robotics. What does this mean is that we have a layered architecture. There is an OS layer, there is a middleware, algorithms, and applications on top. The MedOS part is the bottom 3 layers of the software stack. We use a real-time OS, we use a DDS as a middleware, and then the entire software framework with APIs help you develop hard real-time software. Hardware and the applications developed are actually owned by the users of this MedOS system. Now people can say, okay, we are talking about an Android for medical robotics, so why not just take standard Android? Well, the standard Android that we get from the market is not certifiable or conforming to IC 62304 standards. It has not low latency, so it cannot operate at less than 1 millisecond cycle time. It's not secure and reliable, suitable for use for a class 2B device, and of course we have issues on like scalability, interoperability, because ROS support, DDS support are all missing out of the box from standard Android. Engagement model is described in this slide. On the left hand side, we have the free and the open source version called MedOS Research. In this case, we use a Linux RTOS preempt patch along with OpenDDS. And the beautiful thing about this like product is that the APIs for application programming have been kept similar. So if you are a university or a non-product organization, then you're free to use the MedOS Research. Yeah, you can work on your like hardware and focus on developing your applications until and unless you're able to uh, justify or validate your solution. You do not have to pass it through a certification. But the moment the startup or this organization or this like research group has decided that they have created enough value to validate their business case, then they can shift to the uh, enterprise version of the MedOS, which offers them certification, and this can be also used for profit. And here is the link between open source part of the MedOS versus the enterprise part of the MedOS. What else need to be added here is that because this is a robotics system, we have kept our APIs very similar to ROS. So you can, if you're a ROS user or you want to use ROS, we are compatible with the so-called real-time ROS-enabled APIs. Three technical foundations I want to discuss. One is called SREM. This is called as a synchronized real-time execution model. This SREM enables users to write applications without worrying about hard real-time issues. So the users are basically focusing on writing their applications, and the framework, through its intelligent use of the APIs, are ensuring that the cycle times are actually met. So the second part is the motion planning. We offer hard real time and certifiable motion planners, and these are used not only to like develop your prototypes, but can also be certified. And we also offer functional safety. Now this is something I would like to add, because the future of robotic surgery with AI is asking or driving people to like think about a level 2 or a level 3 autonomy in surgery. Now that's only possible if you have something like a functional safety architecture. Unfortunately, in this like presentation, I won't have time and will not go into details of this functional safety, but I see this as a potential disruption to enable automatic robot movements, to enable a level 2 or a level 3 type of medical surgery. To give you an example of what SREM is, I would show this small video, and here you can get an idea of how we have a modular architecture where there is a planning node, a hardware abstraction node, and we have a state machine coordinator who is ensuring that all the cycle times have been met. So the framework out of the box offers such an architecture so that the application developers can focus directly on writing their IP, but not focusing on ensuring that the end-to-end latency and the data transmissions are safe. On the right hand side, we see an RQT plot. This shows that whatever we are doing, we are fully compatible with ROS tools. And on the right hand side, you also see the system latency. So the left chart, which is around 100 microseconds, is showing the framework latency in a no load setup. And whereas if we do a remote teleoperation demo, then we see our end to end latency in the range of 330 micro or 0.33 millisecond. You can also see how the jitter is so less. The 500, so the like red line that you see with the 500 microsecond is basically the watchdog that is not hit. And now let's go back to applications, what we can actually do with MedOS. On the top left hand side, you can see that we have a setup emulating an RCM motion with our motion planners, right? The video on the right hand side, you see two different robots being controlled with the same input device. So this shows the power of our modular software stack and motion planners, that we can just add any robot, any hardware, and do like similar motion. So we are not focused on a particular type of robot. We can change these robots and we are able to handle it. So this is more or less displaying that you can bring your own hardware and do your applications. The video bottom below, we can see the reactiveness of this demo. So you see how from the same shot that there is almost zero latency, which was displayed in the like plot, and there is actually no delay in the input from the haptic device till the motion of the robot. And then bottom below, you see that there is a ROS simulation on RViz happening, which is of course in the non-real-time world. But then we have two robots with these like chopsticks. We don't want to disclose our IP on instruments, so we just put there two chopsticks, and then we can see the two input devices. And the beauty of this software is that, you know, all of the system is just running on one box. So the MedOS is able to run on one PC box with two arms and two input devices, including a virtualizer that is running on a like separate non-real-time PC. Okay, and I would also like to now focus some aspects on our motion planning framework. So there is we have developed a MATLAB toolbox. These motion planners are actually state of the art, and here you can see how we have another input device from Happily, and we have different kind of robots, and we are testing our applications. The whole backend is running on MATLAB Simulink with our own toolboxes, and this can also use to like simulate a surgery, do some trainings, and most importantly for us to develop new algorithms for motion planning and control. We're also free for our choice of use of the front end. So the like visualization, it could be a real physics engine, or this could be just a visualizer. In this case, we're using here Blender. We can see how we can do some kind of a clutching behavior. We can switch the robots and also do an endoscope motion, as you can see on the right side in the figure. Okay, so Ross for Medical, I started this Birds of Feather meeting last year in October at Roscon. There is where I first did the first Birds of Feather meeting for Ross Medical, and then we have some traction. So Diana has started this Ross Medical group. You can join her on Ross Discourse in April 24. In May 24, again at the Robotics Summit, Tom was giving a talk on is a medical certified ROS needed. This was in Boston. And now I'm here in June at Hamelin giving the talk on enabling software defined medical robotics. And I'm very happy to say that in 24 October, I will be at ROSCON giving a talk on enabling ROS2 benchmarks. So I think all of you who want to know how those those charts were made, how those those like plots were made, how these benchmarks were done. These are actually needed for the certification and for the FDA audits. And for that reason, feel free to join us at Roscon. Lastly, I would like to talk about some testimonials. So, some people who've been involved with our work have given us some feedback. So, Oliver Beale from Zeiss says this could be the next big thing. We have Francois from Innova. They have a booth down below, and for him, they see that they want to go into the if they want to go into the medical field, then they would need a certifiable software stack, and MedOS could bring in that application layer so that they, as a robot producer, don't have to worry about the entire system integration and the certification of the whole system. Then Ron is also somewhere around at Hamlin, and I have met him last year. And based on our talks, he feels that this will enable him to actually perform the autonomous capabilities inside a medical robotics. Yeah, so I was talking about this level 2, level 3 automation. Then of course we have like Brian Gerke. He has asked me last year to establish a medical ROS foundation, and this would really benefit the open source uh, like projects. And then we have also Spencer Morgan, like from J&J, like MedTech, and he also said that they face a lot of issues what were mentioned earlier. New team members joining teams, and all the people who join a robotics team, they start to use ROS, and then ROS is not usable. But what if we can make a certifiable version of like ROS? Then this would really speed up so many things. And lastly, we have Thilo. Thilo is a senior partner at Roland Berger, and I think he sees this point very clearly that MedOS will be an enabler, yeah, to increase the market penetration of RAS systems, because more and more startups and companies can actually build uh, and bring their system faster to market. And of course, when the forces of demand and supply will come into play, that means this will be easier to use, and of course lower the price. So that's all for me. Thank you so much, and I'm open to questions. Thank you.